In this video, we are going to solve the following integral step by step. The indefinite integral of the tangent of x divided by the cosine squared of x dx. Now this integral belongs to a very specific category of integrals with its own specific method of solving. However, because you cannot learn every method by heart, we will use a general method to solve this integral now, and then when we get the solution, we will come back to this and show how it can be solved much more quickly. The general method of solving that we're going to use is the substitution method. In this method, we are defining a new variable, let's take for instance u, and we want to write it as a function of the old variable x, such that our integral simplifies a lot. In this case, we will use that u is equal to the tangent of x. Now the second step is to write this dx with the corresponding substitution. We want something to have to do with du. Now this can be very easily found by differentiating both sides of this equality sign. Thus on the left hand side we have du, and on the right hand side we have d of the tangent of x, or the derivative of x, or the derivative of the tangent of x. So we get 1 divided by the cosine squared of x, which is the derivative of the tangent of x, dx. Now if we want to rewrite this to isolate dx, we simply get that dx is equal to the cosine squared of x times du. Now this method wouldn't be called the substitution method if we would not use these two results and substitute them back into our original integral. So what do we get then? We get the integral of, in the numerator we had the tangent of x, which is now just u, so we have u, and we divide this by the cosine squared of x. But we don't really know yet how to rewrite the cosine squared of x as a function of u. So we just don't worry about this now and we copy it. Then we multiply it by this dx, but we found a formula to substitute this dx as a function of du. So we simply write multiplied by the cosine squared of x, which is this prefactor, times du. And now we see that we indeed didn't have to worry about rewriting this cosine squared of x as a function of du, because we can simply see that it drops out. And we are left with the very simple integral, namely the integral of u du, for which we of course immediately know the answer to be 1/2 times u squared plus this constant c, which is there because we have indefinite integraled. Now we want to write this solution as a function of our original variable x. And to do so, we simply use our substitution here to rewrite it. And our solution will become 1/2 multiplied by u squared, and u is the tangent of x, so we multiply by the tangent squared of x. And we don't forget this constant c. And this is the final solution of our integral. Now, as I said before, there is a much easier way and, well, more quick way to solve this integral by recognizing the form of our original integral. Namely, if you have an integral of a function f of x, it can be any function you like, and we multiply it with its derivative of this function times dx, then the solution will always be in the following form. 1/2 multiplied by this function, whatever it is, but then squared. And in our case, this function was simply the tangent of x. Now, another example of such a function or such an integral is the integral of the logarithm of x divided by x dx. And you can try solving this integral without using this trick and then seeing if you indeed get the same result. If you learned something from this video, give it a thumbs up and I will see you in the next one.